everyone, welcome to the explanation. So in today's video I'll be starting a new chapter. So the chapter name is transaction processing and concurrency control. Okay, so now I'll start a video for this chapter, and I'll continue with all the topics related to this chapter, and after this chapter I'll again go to the another chapter or another topic, we can say. So inside this transaction processing and concurrency control, we are going to discuss about acid properties, concurrent execution, serializability, which is very important concept, serializability in DBMS, log based protocol, and deadlock. So all these 5 topics are very important. Generally you can expect one questions from each topic of this, so I'll try to cover this topic in a very practical way. Okay, so without any further delay, let's start our first talk or first topic, we can say, which is transaction. Okay, so before going to the topic acid properties of transaction, we have to know what is a transaction. So what is a transaction? So we can say that a transaction is a unit of work. A transaction is a unit of work that is performed against a database which changes the database. Okay, or in simple term you can say that a transaction is a unit of work that changes the database. Okay, so any operation, for example, if you are going to transfer an amount, if you are doing an online banking, you are using online banking system, and if you are going to transfer the amount, you are going to purchase anything, you are going to change the database. For example, in your account you have got 5,000 rupees, and if you are going to buy something and do online payment, you are going to change this amount. So this can be example of transaction. Okay, so now whenever we perform this transaction, it is very important to maintain the data integrity and consistency. It means that if you are going to change this amount, if you are going to debit this amount, it should be decreased to some amount, and it should always be in consistent state. It means that now you are seeing this 5,000, and after some time if you come you will see 4,000. No, it should not happen. The data should always be consistent and integrate. Okay, so all this should be followed. So for this purpose only, we have got some certain properties of transaction, we can say. This is very important. You can expect one question from this either in your university exam or in your viva or MCQs. Okay, so what are the 4 properties of transaction? So the 4 properties of transaction are named as acid property, where this A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. Okay, so let us talk about all these terms one by one. So first property is nothing but atomicity. So atomicity, it has come from the word atomic. So can you tell me what is an atom? Atom is the smallest unit which cannot be broken. Yes, same principle we have encountered this word atomic. It means that what is atomicity in a transactions? It means that it ensures that all operation within a transaction are completely successful, or we can say all the operations within a transaction are completed successfully. Okay, it means that if any part of transaction fail, the entire transaction will get aborted. It means that it also tells us either complete or not. It means that if you start any transaction, it should either be completed or it should not happen. For example, we can take a practical example. If you are going to transfer a money, suppose you are using online banking and you are in the verge of sending the money. Okay, so either the money should be totally sent to the receiver or it should not be sent. For example, while sending the money, something happened and your app got closed. Okay, so what happens? Okay, so what will happen? You will not be able to send the amount. Okay, it means that the transaction got aborted. Or if everything is smooth, you are going to send the money, so your transaction has been completed. It cannot be in the between, like your money has come from this your app, but your money has not been received by the receiver. Okay, so if this happens, this means that we are in inconsistent state. So this inconsistency is a very bad thing in DBMS. It should not happen. Okay, so let's talk about consistency in our next term, that is property number B, which is known as consistency. It means that it ensures that a transaction brings the database from one valid state to another. Okay, whenever transaction happen, it should always go from one state to another state. Okay, for example, if you are sending a money, so you are in sending state, and then the next will be you should be in sent state, and then the next would be you should be in received state. Okay, it cannot be in between. For example, if you send your money from here 5,000, okay, you have sent the money, but something happens in between and the money has not been received by the receiver, but that money has got debited from your account. Okay, so this is called an inconsistent state. This is not a valid state. So what does consistency tell? Consistency tell that whenever a transaction happen, your database should always bring your database from one valid state to another valid state. Okay, so if you have credited, if this is your transaction state and if x is the value whose value is 100, if you have created this x value with 50, so the next value should be 150. Okay, it should always be in a consistent state. Fine, let's go to property number 3, which is isolation. Okay, it means that what is isolation? It means isolated. So let me write what is this property. It ensures that operation within a transaction are isolated from other transaction. Okay, it should be isolated from other transaction. For example, it is very obvious that two or more than two transactions they are happening parallelly or concurrently, we can say they are executing concurrently. Okay, it means that if two transactions are happening concurrently, this transaction T1 should not interfere with this transaction T2. There should be no interference among the transactions. Okay, so here we can say that all the transaction in a database, in a DBMS, there are number of transactions happening, so all the transactions should occur independently. They should not interfere each other. Okay, now the fourth property is, I'm going to write here only. So the fourth property is durability. So what is durability? It ensures that once a transaction, once a transaction has been committed, it will remain so in case of failure. Okay, so what is durability? It means that suppose you have sent, this is your account, you have sent money to your friend's account. Okay, so here initially the amount was 5,000. So after you debited 1,000 rupees, your new amount is 4,000, and your friend's amount has been credited by 1,000. It means that after this transaction has taken place completely, which is known as commit state, full and final. So after this, suppose if your app got hanged, if your internet goes, if something happens to this, nothing will happen to the amount. It means that after you reopen your app again, the amount will be 4,000 only. It is not going to change. It means that once the transaction has been committed, it will remain so in the case of failure. In case of any kind of failure, the transaction amount is not going to be changed. So this is known as durability property. Okay, so I hope you got acid property. So this is a very important concept. So in next video I'll come up with transaction states. Till then, stay safe and thank you.